Okay, so I, I want to I want to drop a list of problems now. Right, I'm going to put it on the chat, and I want you to just think through it. Think through it. Okay, so I'm going to type it now. Just watch out for the chat. This one would be very easy, I think. Okay, so what do you guys think about this? A pipeline company wants to detect leaks early before damage happens. So think through this problem, right? And do you think AI can solve it? Do you think AI can help you? I want to hear your thoughts, everybody.
Good evening. Yes, it's possible.
Hello, good evening, sir. I don't know if you can hear me.
So, did anyone get the question? Has anyone spoken?
Good evening.
Yeah, good evening, Quadri.
I feel you can use AI to detect kid
You
before it
can go
happens.
on.
You can just maybe use past records of when it's the pipeline, the age of the pipeline, the type of material as the like feature to determine maybe if there's going to be a failure or not. You get what I said?
My network has been acting funky. What did you say?
I said we can use like past data of repair date, type of the material that was used to make the pipe and the age of the pipeline. Hello?
Okay. Yeah, I got that. So, what kind of data are we talking about? What kind of data?
I said the age of the material, that is the age of the pipeline, the type of material, and the past dates of repair.
Okay, well, that's possible actually. That's possible. We can use those things to determine how long the pipeline will last. But then, how do we know what type of data would we need to know if like there is a leak? The original question I was asking was, what's the form of the data? Could it be text? Are we going to use text for it, or is it going to be like images, like what
Image
we
of
saw?
videos.
Okay, okay, image or videos. Okay, that actually works also. That works. You can also use, okay, anyone else? Anyone else? Or do you have anything else to say, to add to it?
Nothing.
Can use yeah, we can use image and videos from it. What PK said yesterday, where he was where he was explaining how he makes use of the underwater robots, right? For gas, say for gas, sorry, for pipeline um leakage detection. And also you can also make use of data sets. Now data sets, most people they usually simulate like what he said yesterday, even in the field of robotics when where he was talking about simulation. What most companies do, they simulate, even companies that, okay, so for example now car companies they usually simulate their cars. Like if this guy is under this amount of load, or if this guy is even moving at this particular speed, right? How how quickly will this car tend to damage? Like how will this car damage on time? So most of what companies do nowadays, they don't usually um, build this particular prototype and then destroy it. They usually use simulation because they tend to they observe that, okay, if I can simulate this thing, right, and if okay, they tend to simulate it, right. So if they can simulate it and get results, and most times, right, that results always like is always same as when they even destroy it. Because what they do before is that they build this particular thing and then they destroy it. And that is just in testing phase, and that is no good. So over time, people started using simulation. So now in pipeline monitoring, right? So they can simulate a particular pipeline, put sensors, because if a pipeline should burst, right? What are the parameters that you need, or what will even happen? So for example, now if a pipeline should burst, the things that will change are the pressure, because the pressure will definitely change, right? The volume too will change, the temperature will spike. What other things? The time that pipeline got busted or leaked due to corrosion of the pipeline itself. So what CFD engineers, what they usually do is that they perform CFD, and what is CFD, computational fluid dynamics, right, on that particular pipe. So they get the results and then they give it to the ML engineer. So, but before they give it to the ML engineer also have an idea of what that pipeline, like the pipeline looks like. So he or she will definitely tell them the parameters that you work with that will best define how a leaked pipe will look like. So yeah, that is what I have to say.
Okay, thank you very much, Daniel. Does anyone have anything to add or any questions to ask Daniel? This session
You,
is next. Okay, go on, Blake.
you were saying ways to get the data. You mentioned Baker mentioned something about acoustic, like using sound.
Yeah, that's
Sound,
to do with sound.
yes.
Sounds.
Yeah.
Yeah, go on.
Then drones to monitor real-time monitoring data gotten from the videos. You talked about using videos. They have softwares where they reduce the resolution and they they're able to get exactly the features they need to process and analyze data they need for prediction.
Okay, thank you. Thank you, Blaze. Anyone else? Anyone else has anything to add, contribute, or questions? Okay, I'll take that as no. So, okay, Mazuk, you can ask your question. You guys don't need to raise your hand, just chip in.
So the question is, say, how do I put it? Say AI can help. I mean, how do you use AI to detect all those kind of stuff, right? I'm correct. So what I think, I don't know what I think, what I because if pipe is leaking, there will be physical, like there will be physical properties. Let's say like depending on the contents that the pipe is carrying. So surely I believe we can use text to I mean we can do it in text instead of just pure videos. That's what I have to say.
Yeah, that makes a lot of sense. I'll talk about that too now. Does anyone else have anything to say to that? Maybe counter or to support it?
Okay. Good afternoon. Good evening.
Good evening, Jeremy.
So I wanted to ask, like, pipeline is a large scale. It's large scale. It spans hundreds of meters, sometimes goes through countries, territories. So how do we get the sensor to be able to measure everything at every particular time, or is it like um a regional thing that they do maybe once in a month or twice in a week, or is it real time? So how do they cover that much land area?
Daniel, do you want to answer that? Daniel, are you with us?
Yes, I'm with you
Okay.
guys. Yeah.
Okay. Do you want to answer that?
I don't know. I have an idea actually.
Okay, okay. Go on.
Okay, so the idea I have is okay. Let's say the pipeline is on land. I don't know about water, right? If the pipeline is on land, from what I know, right, manually, what they usually do is that people usually walk along the pipeline and then check. But now you have the workforce has to be large. You have to have about I don't know maybe 1,000 people because pipelines are usually they are very very long and usually span a very large distance. So what companies usually do, right, is that they make use of UAV, that's unmanned aerial vehicles, for example, drone, right? So they use a large amount of drones. But now to control those drones, I guess it's called SLAM, simultaneous localization and mapping, where the drones they can I don't know they can coordinate themselves. Now you have different drones. So if checking this part, if I'm checking this particular pipeline, I don't expect the other drone to check that same pipeline, right? So we have those drones. There are many. Okay, for example, let's say there are 5 drones now. Now you have a very large scale, let's say about 200 acre, right? And the pipeline spans that large distance. Now I need those 5 drones to check the pipeline. Now the pipeline is not just one, it's not two, it's not three. So now what they usually do is that they control those drones, right, to span that large area, such that if one drone is checking this part, I don't expect the part that former drone, right, should check. Like I don't expect two drones to check what I've done before, except I want to check it again, right? To be sure that okay, there's a leak here, or there is no leak here. And also when those drones are checking, those drones they already have um this AI in them or ML in them, that okay, that they can sense leak due to computer vision, because they have cameras embedded in them that can actually look at this particular part of the pipeline and say, okay, there's a leak here, or there's an anomaly, right? Something that doesn't look normal, right? So that's what most companies use, right? UAV, they use drones. And what else? Okay, recently they started using this thing also. They started using satellites, right? They put the satellites in low Earth orbit, right? But what they usually use it for is methane. That is what I know. I know that they use it for methane gas. So they use satellite also for that large amount, that long pipeline, because you don't expect human beings to be doing all of that again, because the world is advancing. Sorry, the world has even advanced safe, and the technology becomes better every day. So that's what most companies, most oil companies do. And what else? There are so many. There are other. Okay, there is one that combines everything together, right? There was one I read on that combines everything together. So it combines UAV, combines satellite, like it combines everything to a particular framework, right? So that the results are very, very accurate. So after the UAV has done its own work, the satellite will also do its own, and then they combine those results together, right? So as to get a better result, or a better confidence score that okay, yes, okay, there's a leak here along the pipeline, or if the pipeline has no leak and the pipeline is okay. So yeah, that's what I have to say.
Okay, thank you very much. Now, to address Mazook's question, because we are somewhat drifting away from that now, and I want us to cover what we can. So, I have another question for anyone. So, as Daniel has talked about the use of drones, right? But what if you don't want to use drone to monitor your pipelines? Like, if there's a leak now, what other way can you use to detect? Drone just uses visual data. It's what it sees, right? Assuming there's a camera on the drone. But because that is like resource heavy, you need a lot of battery, you need a lot of compute resources. So how else can you like monitor this? Now, the question Mazook asked might give a hint on how to go about this. And we've somehow talked about this earlier. So how else do you think we can actually monitor these pipelines? Text is going to be the format of the data. So what do you guys think?
Okay. I think he said that that most like when there's a pipeline leaks, there's a lot of physical quantities that like occur. Something cannot just leak and everything will just stay the same. There's going to be a breach in like the system you get. So a way for them to know where there's a leak is that they measure it with physical quantities. They have like pressure now, and I'm sure that like every pipeline there's like it's not just there's valves there's valves at intervals. You understand? So they can be measuring the pressure like per time. So as they are building the pipeline, they will just be inputting the pressure sensor at every interval. So when they know that the pressure has reduced from this point, they can know that okay,
the vandalism must have happened or the leakage must have happened between maybe section A 34 between section A 35, so they can know with all those things because of pipeline is very expensive, oil is expensive, so because of that most companies do not want to leave it to for chance, you get. They want to like invest heavily to protect the resource. So they will go all out to see how to better efficiently monitor and safeguard it at any instant. I know that they are investing millions of dollars to see that they can just better and effectively safeguard it. So even yes, drones is expensive and computer vision, but they are also like infrared rays. They are like they can use like instead of just they can just monitor, okay, this part of like heat sensors and almost all the stuff like that sha. So that's what I think.
Does anyone have anything to add to that? Okay, so Jerry, do you have anything?
Sorry, Sam.
Yeah.
Yes, like, can you repeat the question? It looks like
Okay. I was asking that what if we don't want to use drones or visual data? What else can we use to monitor? Right, and Jeremy, you've even answered your question. There was a question asked before. You said, "How does it cover consistency?" You've already answered it yourself. It's not use of sensor, right? So if we have a pressure sensor along the pipe, let's say point between points C and D. If the sensor, if the pressure at C is not the same D, right? We know the pipe is flowing from one place to another. If it's the same, we can tell that was within this region. That's type of problem called leak localization. Trying to figure out where exactly the type the leak occurred. You see the other things that we've even thought of how you can monitor this. So do you have anything to add to that, Karen?
yeah. So I don't know if my answer is like really, really smart, but let me just assume that there's no smart answer in this case. Yeah. So I'll contribute the small that I know. So he made a very good point. I think what I had in my mind was sensors, but I didn't just know the right words. I didn't know the right words to use because what I had in mind is okay. Probably if they have, I don't know if it's, will I call it, like, I'm using movies to imagine it, and I think I've seen it in a movie where they have something that they just implant on each pipeline, and that just monitors it. Like they have it in different parts of the pipeline. I don't have an idea of how long pipelines can be, but let's say they have it at different sections, just as he said, and they all give feedback to a particular system. Yeah. So if there is anything wrong with any pipeline, it picks it up and they know that they have to quickly attend to it. So that's the, I don't know how to explain it in computer terms, but the image, like, it's in my mind, and exactly how I'm picturing it is how I'm explaining it. So that's
Okay, thank you very much, Karen. Masuk, your hands were up before. Do you have anything to add to that? Anything at all?
Um, I was going to say that actually, in where I did my IT, yes, there are sensors like that that check pressure, that just check the pressure and send it to like a central system. But this one's on a very small scale, though. But still, it's a lot of pipes.
What kinds of pipe? What was passed through the pipe that you
So
guys
where I
used?
did my was in breweries, Heineken. So in the pipe, at intervals of this, like a pressure sensor that delivers it to the system. Then it goes to the brewing that's to the brewing team. So they are done that like check the pressure and each time they notice a leak between a section, and they send the welders, which was the team I was part of, to go and check it out and change it. Yeah. So that's just how it works.
Okay, thank you very much for that. Thinking about it, there's even I remember seeing this on one of our sessions that there are even devices you can put inside the pipe, and Bakel talked about it yesterday too. I can't remember the name they are called, but you can assume they are robots, right? Some of them, well, I think it's an emerging field. Some of them are there to fix breakages in the pipe, to repair the pipes. While some of them are because they move around in the pipe, and I can't even imagine how it even sounds crazy. Like if you are transporting oil, for example, oil is very black. So I don't want to assume there will be a camera with the robot because the robots will not be able to see anything except maybe it's using sound. Yeah, I think that's where acoustics can come in. But this is just me thinking out loud. Okay, so we've been able to define our how we can get our data, what kind of data it uses. So for the problem, we can see that okay, you can ask the question: is there a leak anywhere on this pipe? Yes or no? Right. And if there's a leak, where is the leak located? That's what you want to know, right? So I guess we've covered that. Does anyone have any question on that? Or anything else to add?
Yeah. So to add to it, I think that option is even a cheap option. I don't know, but there's mm, car wheel sensor. That car wheel sensor is very cheap, maybe like 5K. So I feel like it's actually a cheap option and it's a very viable option. Just to add.
What sensor is that?
Sorry, I didn't get it now. What do you say?
You said a sensor is very cheap. What sensor are you talking about?
Yeah, I was comparing it with car wheel sensor because I feel like everything just uses the same principle. I think I'll make research on it. I don't know if it uses the radar or the sonar or the lidar. That's either the sound or light. But yeah, it's still the same principle to get the speed. That's speed, pressure, and stuff. Yeah.
Oh, you mean car wheel?
Yes, car wheel.
Is that
Yes.
a,
With speed
oh,
sensor.
oh, car wheel. What did they use the sensors? You said for speed.
Yes, that I mean like those sensors that they said to be put in at intervals. I feel it's still a cheap option. Yeah.
I never even thought that the sensors would be on. I want to assume they are encoders. Maybe they are called encoders, wheel encoders. Because in robotics, no, that's the term I hear, where it tracks every revolution and it uses it to measure maybe distance. Well, that's if you say they operate on the same principle. That's really nice. Also, I will check it out. Okay, I have another question. Let me see. How do I frame it? So, say you have students in a class, right? Assume maybe you're a lecturer. You have students in a class. Do you think it's possible to predict students that will fail a course or not? Let me first ask that. What are your thoughts on that? Can you predict whether a student is going to fail or not? Anyone wants to try? Donald, we've not heard from you. Usman, Michael, Oluwasegun. Okay, Mazuk, you can go ahead.
I don't think it's predictable because if let me use like one of my favorite examples, Godfather. If you see that boy in class and outside class, you cannot predict that he's a first class student.
That's a very good example. You know, when I heard, when someone told me Godfather was also doing machine learning, I was like, this guy, this same guy, not that I was underestimating him, but then when you look at him, you see him as someone that jokes around a lot, that he seems carefree, plays a lot. Uh, uh, don't you think Godfather is going to be an outlier? Like maybe it's not the norm. So you don't think it's possible to predict whether a student will fail? Okay, let me ask you this then. If a student does not read, if he knows nothing about the course, won't you be able to predict that this student is going to fail? Like if he knows nothing about the course and he goes to sit for the exam, ideally, is that not how it's going to be?
Well, I don't know, but depending on the data that you feed the AI, right? But let me say from a lecturer standpoint, and even from a friend, if you're not with such a person 24/7, you cannot really predict them. So yeah, I'll say it depends on the data that you feed. If it's like you feed the whole life of the person, which I don't think is possible to the AI, so yeah, it's predictable. But if not, no.
That's a very good response. It depends on the data you have. Yes, it depends on the type of data we're even gathering. Does anyone have anything to add? Me, I wanted to even say you can use AI to predict before. Okay, carry on.
For me, you can't predict. You can't just predict if a person will fail. Because I know so many people that are not really serious in class. So when it comes to the exams, they perform well. Most people, some people don't find reading in class. Like they don't fancy it or paying attention in class. They believe they can do it on their own when they are in their closet. Like they can just find their way around that topic or that course when they're in their closet and then do well in their exams. But there's one thing I know, I don't know. I noticed that people are abroad, right? And I'm not being stereotypical now. Like abroad, people abroad, or when they school, or people that, okay, for example, let me say MIT now. So it's what I've seen and what I've watched, right? I noticed that if you don't focus in those people's classes, like those prof classes, you can't even do well in the exam because I've seen some of the exam questions and then most of the students that say they do well, they are students that usually pay attention in class. Like those that don't pay attention in class, right? They usually have issues. But now, those that don't pay attention in class, if they can ask for the lecture materials and then they go to the problem set and they meet their TA, that's their teaching assistants, right? And here in Nigeria, we don't have TA. You can't really meet anyone. So I would say it depends, like as Mazuk said, depends on the data you feed it. And depends on the environment also. I would say the environment is also part of the data. So yeah, you can't really predict. It depends. You can't really predict. At times you can, at times you can't. If if it's I don't know, like if it's around the particular environment, you can actually predict. But if it's not around the particular environment, you can't predict.
Okay, thank you for that, Daniel. Does anyone have anything to add?
Okay, can I add something?
Yeah, go ahead.
Like, can I add something to what Daniel said? Like, another thing you should also factor in is the lecturer. Yes, the lecturer, because there are some lecturers, they are difficult people. Yes, so with some lecturers, you can predict, okay, even if someone doesn't read for this course, there is a tendency of this person doing, well to a certain extent. If the person reads, yes, and for other lecturers, if you like, read the course. Like, there are some people that they know. I don't know. As funny as it sounds, it's the truth. There are some lecturers that they are just difficult. Yes, no matter how much you want to read, you will not pass the exam. Yes, and there are some, even if you don't read for their exam, at least you probably get like, let me just use last week's grading system. You get at least a one. But for some lecturers, you will read, 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 read. It's still one that you will carry. So another thing to factor in is the lecturers of the university.
Well, thank you for that. Well, I hope you know what you can do or cannot do. It's not dependent on opinion. It depends on if the data is available. If by chance there's actual data, because certain prediction, when you think of it in a rule-based manner, it makes sense. Also keeping in mind that AI uses probability. Right? So if we are doing something like that, what we are getting from the model is a probability. It may not always be correct, but it's still a probability. Let's talk about ideal situations now. You don't know anything about the course. You don't know nothing about the course. I'm one of Nigerian lecturers also, but normally you don't know anything about the course, and you go and sit for, and you did not read about it, and you go and sit for the exam. 100% chance you are going to fail it, right? For that case, you don't even need AI, right? That's rule based. They call it heuristic, right? That's rule based. Now let's say we decide to add in other factors. How many times did you come to class? Because believe it or not, let's use this. Let's use school for example. If you know Dr. Ajasa, if you notice, if you don't attend this class, it takes time for you to grab, because at least for me, I don't know who to meet. People will just be saying they don't understand. But me, I know that once I'm in the class and I learn it, I understand it there. I just need to revise it to remember it. So it's a good teacher that way. So there's a high chance that if I come to, you see, I use the word chance here. If I come to Dr. Adasa's class most of the time, there's a high chance I won't fail the exam. You can likely use that to predict that I'm not going to fail the course. So this is just my own point of view. If the data is available, you can surely use it. Remember, I said it depends on data, and if it's not available, you can't do anything. Okay, another problem here. Say you want to, if I use this word now, you just assume it's AI. But let me even hear your thought process about it. I want to ask questions here. Say we have a spam detection problem, that email filtering. You want to determine whether an incoming email is spam or not. Right? How do you go about that? How do you go about the process? What's the first thing you would want to do or you try to do? Let me hear your thoughts about
Good evening.
it. Yeah, go ahead.
Then I feel you get the right data set. Then after getting the right data set, when you create your model, you give chance for users to like, the thing is still a probabilistic stuff. So users can like by themselves they can determine that this is spam. So when they see that kind of email, there should be a place they can send that kind of email. So you can use that email to train your data set continuously.
Okay, that actually makes sense. But let me ask you this: the model that let's use your example now. Are you saying if you mark an email as not spam, they are going to send the email to Google server so you can use it to train model? Do you think that is what they do? Would you also give your data out like that?
So please, I didn't get what you said.
You said users should be able to get the option of still seeing the mail and determining whether it is spam or not. So if they mark it as not spam, do you think the because you want to improve the model, right? Do you think that mail will be sent back to Google so that and they can that that mail and the label whether it is not spam will be sent to Google for it to like improve its model?
Yes, it should be sent back to Google to like improve its model. That's just like
Well, I don't even know if that's what we don't sign into. Maybe it must have been in the attempt. But if that's what actually happens, it will be insane. That means Google can read all our mails. The other option would be that they don't use it to improve their model. Once you click on not spam, it just enters your normal inbox. That's the idea. That's the idea behind it. Now, what kind of problem is it? Are you trying to predict a number out of the number, or are you trying to classify something? What kind of problem do you think it is?
please can you like recap?
I said, what kind of problem is this email filtering? I'm trying to predict a number um, from the mail, determine whether it is spam, or are you trying to classify the mails?
I feel classifying works with data.
Yes, it is classifying. Whenever you're doing machine learning, you're either trying to predict a number or you're trying to classify. or then we are doing reinforcement learning. We have, we have supervised learning, unsupervised learning. We have reinforcement learning. Let me give you one a high level overview. When you're doing supervised learning just the word explains the meaning supervised. It means you're supervising the model. What that means is you are guiding the model. How do you guide the model? Let's, for instance, this problem we are trying to solve, whether it is spam or not spam. What do? How do you guide the model? When you get your data, imagine your data is like tabular form, right? See, one column, you have the mail content itself, and on the other column, you have something called, that other column is called your target variable. It's the entries on that column will be spam or not spam. So for different mails you have, it is being marked as whether it is spam or not, right? So that will telling your model, look at this email during the trade process. That's what it is. Look at this email, it's not spam. Look at this one, okay, it is spam. What's the difference between the two emails? What makes this one spam and not spam? Model will now have to uncover patterns in the data. Maybe if it's things like hire me now, hire me very quickly. Like all these phishing emails, there's a
Man,
way to write, right? There's a way to write.
anyone sound that can around this place.
If you see how they are written, your model will be able to understand that. Now, the data you have most of the time, it will not be written out explicitly that it is spam or not spam. Sometimes you see 0 or 1 because in machine learning, you typically represent them with numbers because it's numbers that computers understand. So model will understand numbers. So it could be as it could be seen as 0, it could be seen as 1. So that is supervised machine learning. We are using labeled data sets. That's labeled data set. Data set that has label. So that label is that target that you are trying to predict. Eventually you are trying to predict, given an email that's coming in, is it spam or not spam? That's what you are trying to do. So that is supervised machine learning. And in supervised machine learning, commonly two types of problem. We have regression and we have classification. For regression, we are trying to predict a number. If anyone, okay, if you've done linear regression before, that's regression. That same formula is being used here in machine learning, and I think that's like the most important formula, or the most, should I say, impactful formula in machine learning. That y equals mx plus c or b. That's like the most important. We'll get into this next week, but just know y is what you are trying to predict. So y equals mx plus c. X is your input variable. What the model is now trying to do is the model is trying to find the slope and maybe the intercept, or you could include an intercept. But once the model gets to the slope, whatever inputs, whatever x you have, and the intercept, you will surely get a certain y. So what your model is trying to do is trying to find the pattern, the correlation between some feature, and that's your slope. Slope is rise over run. So that is regression. Trying to predict a number. Example would be predicting maybe how much maybe price would be maybe tomorrow. So for prediction, your output is usually a continuous one. You are not predicting that it is 1 or 2. that you are predicting that it should be a number in between. That's regression. For classification, you usually have discrete outputs. So for this email function now, whether spam or not spam, it's falls under application. Right? It will either be 0 or 1. It will either be spam or not spam. Discrete values. The range is discrete. You can't have 1.5. You can't have something that's spam and not spam at the same time. If that makes sense. So that's classification. All this is still under supervised machine learning. Then we have unsupervised machine learning. They are not using labeled data sets. In one of our classes, I talked about customer segmentation, for example. For unsupervised learning tasks, you just take your data and take it to the model. And the model, you don't tell the model what to expect. Right? You just let the model figure it, and the model figures it out. So for customer segmentation, now, you just take your customer data and feed it to the unsupervised model. You are not doing a classification algorithm. You just want it to classify all the customers somehow. It can do that. And from there, you see patterns. Okay, customer that stay in particular location, maybe they like to buy your products or just cover in, right? But the biggest use of machine learning, about 70% of machine learning, typically supervised machine learning, particularly regression. You're trying to predict a number. That's like the biggest use case. I've, and then we have reinforcement learning. Let me just brief on that. So for reinforcement learning, it sounds the way it explains the way it sounds also. We're trying to reinforce something into what we call an agent. So in this case now, whether you are using a model or maybe a robot, they're not called agents. Something that's trying to learn is an agent. So what reinforcement learning does is that you don't have data in the typical sense that you have data for these other types. What you're trying to do is, okay, be this way. I just drop an agent in an environment, right? I drop it, and I don't tell it what to do. The model can carry out, the agent can carry out any number of tasks, right? But let's say, whenever the agent, let's say the agent is stationary. Whenever the agent is jumping, I give the agent a score. That score is a positive feedback. I give it a score. Now, in reinforcement learning, the goal is to maximize that score. That score is called reward, right? So what the agent is going to understand is that every time it keeps jumping, it gets a reward. So the agent is just going to want to continue jumping. So that's reinforcement learning in a nutshell. You don't tell it exactly what to do, but you give it scores for what it does. And then over time, it begins to learn that certain actions like give back certain reward. That is reinforcement learning. It is used in games. Think of, you can just imagine the use case of it. It is used in robotics too. You put a robot somewhere and then you don't tell it what to do. For example, these robots that play soccer now, all these autonomous robots, it's particularly used for autonomy. If you want something to behave autonomous, you just define the goal. I want you to, let's say, I want you to take this cup and move it over there. Right? That is the goal. Whenever the agent maybe picks up the cup, you assign a reward to it. Now, most of the time, it won't always pick up the cup immediately because they could be like infinite actions that the robots can do. But maybe you could set it in a way that as it gets closer to the cup that it wants to pick, the score is increasing. Like you get, so the scores is usually not just 1 and 0, 1 and 0. It could be like 1, 2, 3, 100. Then maybe the farther it goes away from the cup, you are subtracting the score from it, if that makes sense. So it's a very interesting field. There's still a lot of things inside this field also. It extends beyond just software to hardware and all that. But it's usually like There's usually a lot of maths in it if you really want to understand it, but it's very interesting. So I guess that is that. Does anyone have any question or anything to add?
So may I have a question on my own journey? Please, how far should I go in Python before I move? My goal is machine learning. So how far should I go in Python?
Did you say how fast or how far? What your question was? How fast or how far?
Like, what should I stop? Because they're like, you do have to learn Python completely, like finish. So I want to know like where I'll stop.
I can't tell you where to stop. I can't tell you where to stop. But take a Python course. If you take a Python course, anywhere they stop. It doesn't matter. You can throw yourself into the unknown. What I mean, like Beto was saying yesterday, that he doesn't like learn something completely. He wants to see like the actual use case of the little things he has built. So different styles for everyone, but the fundamentals. Always learn the fundamentals. Once you learn the fundamentals, you can go from there. For the course I recommend then on Coursera by Andrew Henry, it's not mathematics heavy. It's not mathematics. It's like it's not mathematics at all. So if you know a bit of Python, if you've learned the fundamentals already, you can go and take that course. The reason is that applying for financial aid, the course has small labs inside. Those labs usually have code, and sometimes you have to run the code. And you just click on run to see what the code does. Sometimes they'll give you tasks where you have to like maybe edit the code to pass to the next and that. So you need Python knowledge for that. So I can't tell you exactly where to start, but just make sure you learn the fundamentals. And we'll be having a Python session next too. I guess that's that. Any other question?
Yeah, I have a question.
Okay, go ahead, Daniel.
Yeah, you talked about reinforcement learning where you give the machine learning model a computer score for you made use of jumping. Right? I guess you said jump, no, not jumping, I guess walking. And I guess Baker also talked about it yesterday when he was talking about the this robots, this dog robot, right? Where they made use of reinforcement learning and then when it jumped, and oh, sorry, the model noticed that if it splits his leg too much, right? They gave it a high score and then it started jumping, like splitting his leg too far to fall flat and jump on back. But now you said they usually give it a confidence score. Now, why were they not able to fix, like, why were they not able to solve the problem? Because if it jumps too much, they can give it a score that, oh, I jumped too much, you're not going to jump that far. And then you should do what is needed. And guess what was needed was that you should run, not jump. But as Becky explained yesterday, it was like when it turns that he gave it to a very high confidence score, like when it extends his leg, like he gives a very high confidence score. So my own question is, why were they not able to solve that problem by giving it a low confidence score when it extends his leg too far? I don't know. Is there a way to solve that kind of problem using that same reinforcement learning, or
There is.
okay? There is.
It
All
just
right.
depends on how. It just depends on how you frame the. I think there's something called policy. Policy is like the rule. It just depends on how you
All
frame
right.
the rule, right? So think of policies as mappings that guide. Um, the guide is a mapping of state to action. Meaning, if a robot is in this state, it should perform this action, and when it performs this action has a reward also. So there's a policy for that too. It's not that it is impossible to do. Maybe it's just something they observed and he was talking about it. He wanted the model to learn to sprint. And then the model
Yeah.
figured out that if it opens its legs so wide, it gets a certain reward. They could add it. They could add to it that if the model is if the agent is stationary, it doesn't get a reward. They could add that too, and the model will know that it always needs to move. But it's not thinking of it logically this way. It's not like crazy complex, and I don't want to assume it's a problem they were facing. Right? We know what to do. They know what to do about it. It was just an observation. So, because you know that you're not telling the model what to do. In reinforcement,
Yes.
the agent, you're not telling it what to do. You're only like guiding his action with rewards. So it figures out what to do. And then if you don't define it well, the agents can try to exploit the rule you set to maximize its reward. And that's just what was happening there.
All right. Thank you.
Yeah. Are there any other questions? Okay. I assume there are no questions. So I guess this is the end for today for now. We have an external speaker joining us tomorrow. Meanwhile, I want to encourage you guys to put yourself out there. Also, it is important. Participation is important also. It counts towards certificates. So, just asking questions. I said it before. This call is being recorded, so everything is being tracked. Your attendance, your participation, it all counts towards your certificates. So, I guess that's all for now. I'll see you guys tomorrow. If you have any questions, you can ask in the group. You can ask any of the admins you see on the group. So thank you all for joining and cheers.